In this video, we're going to look at a proof of this theorem. Let F be a field. Let N and A be n by n matrices with entries in F. If n times A is I, the identity matrix, then A times n is also the identity matrix. The proof relies on the following claim. The system Ax equal to y has a solution for every choice of y in Fn. In other words, no matter what right-hand side we put in, there's always a solution. We're going to prove this claim later on, but let's see why this gives us what we want. Let y be an arbitrary element from Fn. So by claim, there is x prime in Fn such that A times x prime is y. This is just a fancy way of saying that x prime is a solution to the system Ax equal to y. What that means is, if I multiply both sides by n on the left, we'll get n times Ax prime equal n times y. But I know that n times A is I, so this gives us I times x prime, which is just x prime, equal to ny. So we can write y is equal to Ax prime because of this, but x prime is just n times y, and by associativity I can rewrite this as this. But y is arbitrary. It could be anything in Fn. The only way this is possible is for this to be the identity matrix. Since y is arbitrary, A times n must be the identity matrix. And that proves the result. So all I have to do now is to prove this claim. So how do I do that? Well, suppose this is not true. Suppose that y prime is such that Ax equal to y prime has no solution. And we row reduce the augmented matrix Ay prime to Rd, where R is in reduced row echelon form. Since Ax equal to y prime has no solution, this matrix R must have a zero row whose corresponding right-hand side value in D is non-zero. So I must see a row that looks like this, zeros, and then something here in D that is not zero. Because R is square, that means that not every column is a pivot column, so there must be at least one free variable. R must have a column that is not a pivot column. So there is D in n of A, D not identically 0. But what that means is D, which is the same as identity times D, and that in turn is the same as n times A times D. And by associativity, that can be written as this. And that is just n times 0, and that's 0, which is impossible because we assume that D is non-zero. And that proves the claim. So no such y prime exists. So with this claim proved, I have proved this theorem.